binomial probability distribution. The probability of r number of successes out of n trial of random experiment is given by binomial distribution, which is defined by p of r, that is probability of r successes is equal to ncr into p raised to r into q raised to n minus r, where p is called probability of success, or it is a probability of event in a random experiment. Q is equal to 1 minus p. That means Q is a complement of p. That means complement is a set which you know as S is a sample space and A is a event. Then remaining result in sample space, that the shaded part is called A complement. As we know, probability of A is always less than or equal to 1, and probability of A complement is 1 minus P of A. Okay, so P is a probability of success, then its complement Q is a probability of failure, and it is equal to 1 minus P. And this, using this formula, P of R is equal to NCR, P raised to R, Q raised to N minus R. We can evaluate probability of R number of successes out of N trials. As a random experiment is repeated, then the repetition of that random experiment is called trial. If we toss a coin, then it is called random experiment. If the same coin is tossed again and again, the number of times it tossed is called trials. If we toss the coin 5 times, then n is 5. That is, number of trials are 5. If we toss 10 times, then n will be 10. Similarly, if n is 8, that means 8 times we tossed the coin. If we want head to face on the coin, that means the event A is getting head, and this probability of getting head of random experiment is called here probability of success. As we tossed 8 times, and out of these 8 times 3 times we get head, then here 3 number of successes we get. If 7 times head is appeared, then we get 7 successes. Similarly, out of these 8 we can get 0 successes, or 1, 2, 3, and maximum 8 number of successes. That means R is having value 0, 1, 2, 3, 8. Now if we want 3 number of successes, then we denoted by it as a P of 3. That is probability of 3 number of successes. If we want 7 number of successes, then we represent it as a P of 7. That is probability of 7 successes. If we want none number of times we get head, that means we want 0 successes, then we put it as a P of 0. As P of 2 means the 2 number of times head will appear out of 8 trials. Okay, do you understand? P of R mean, now to evaluate P of R, we have to remember this formula. In this formula we came across one concept, combination. This is a read as a NCR, and value of NCR is always n factorial divided by n minus r factorial into r factorial. As this is a calculation method, you need not use this, as there is we use scientific calculator and it has this function NCR, as you can observe on your calculator, and it is easy to evaluate value by using that function NCR. Now to remember this formula, we know there are 3 terms. First is NCR, second term is the probability of success, and third term is the probability of failure, that is complement of P, as P raised to R and Q raised to N minus R. So P of R is equal to NCR, p raised to r into q raised to n minus r. So probability of r number of successes out of n number of trials is defined by binomial distribution. P of r is equal to ncr p raised to r into q raised to n minus r. An unbased coin is tossed 6 times. Find the probability of getting 2 heads. Now in a solution, as we understand here, the number of trials are 6. That means a coin is tossed. The tossing a coin repeated 6 times. As you understand here, n is equal to 6. This is a very small number of trials. We use binomial distribution if number of trials are small. Actually it is less than 20, then we use binomial. Otherwise we use the next probability distribution, which is called Poisson distribution. Now n is equal to 6, so we have to use here to evaluate probability of r number of successes out of given 6 trials using binomial distribution. Now by reading this example, we understand we have to find probability of getting 2 heads. That means getting head is our probability of success here. Yes, therefore P by tossing coin, as we know the sample space is H and T, as we have to find here getting head, that is n of A is here 1, as P of A is always n of A divided by n of S. Now n of A is 1, n of S is 2. So getting head is a probability having 1 by 2. That is probability of success is here 1 by 2. Now we have to find Q, as we know Q is a 1 minus P. So 1 minus half is again half. So P is a half, Q is a half. That is P is the probability of success here, Q is the probability of failure. We can say that means we use n, we find n p q. Now by using binomial distribution, as we stated, number of trials are here less, so P of r, that is probability of r, is equal to formula given by NCR P raised to r into q raised to n minus r. Now here in this example, take as r is equal to 2, as we have to find getting 2 heads, that means 2 number of successes. Therefore P of 2 is equal to here, P of 2 is equal to n, that is 6, C, r is 2, P is equal to half, raised to r, r is again 2, into q, q is again half, into n minus r, that is 6 minus 2. Now simplify using calculator, as 62, that is combination of 6 out of 2, you can evaluate it, half raised to 2, half raised to 6 minus 2. Do the simplification carefully and you get the answer as 0.2343. That means probability of getting 2 number of successes out of n trials here is 0.2343. Fair coin is tossed 8 times. That means in solution here n is 8s, and we have to find the probability that it shows the head. Again here head, getting head is an event, so probability of success P is here getting head. As we know probability of getting head is a half, so we find Q as a 1 minus P. Again 1 minus half is equal to half, so we get n 8 P half, Q is again half. Now as n are less than 20, so use binomial distribution. By binomial distribution, probability of r number of successes out of n trial is equal to NCR P raised to r as q raised to n minus r. Now we have to solve first as exactly 5 times. That means we have to take here as r is equal to 5, as exactly means we given equality here. So P of 5 is equal to, by putting the value of r is equal to 5 in this form, as n is equal to 8, so the first term will be 8c5. Now P is a half, so second term will be 1 half raised to 5, and as Q is a half, so we get half raised to 8 minus 5. Again, by using calculator, we evaluate the value of this as 0.2187. This is the probability of getting 5 number of successes out of 8 trials. Number 2, at least one. As here we have given at least is an inequality, as exactly is a equality. At least and at most are two inequalities we have asked. As at least is given, we know there are inequality greater than or equal to, less than or equal to. So for at least we have to use here find r greater than or equal to 1. So we take r greater than or equal to 1. If we ask the at most, then we use r less than or equal to given value. Now r greater than or equal to 1 means r has a value minimum 1 and more than 1 also, as we can take maximum 8 number of value. So r has a value 1, 2, 3, 4, 5, 6, 7, 8. As we have to find the probability of as greater than or equal to 1, so we have to find probability of 1, probability of 2, probability of 3 up to probability of 8, as these are independent events, so we have to add them. Taking this tedious work, we use complement. As r is greater than or equal to 1, we know probability of r greater than or equal to 1 means 1 minus, we have to find probability of r less than or equal to 1, as greater than or equal to is a complement of less than, as r greater than or equal to 1 has a complement r less than 1. Okay, do you understand? So if r is a greater than or equal to 2 means r has a value 2, 3, 4, 5, 6, and the complement of that is r has a value 0, 1, okay, not equal to 2 and more than 2. Similarly, r is a greater than or equal to 5 means r has a value more than 5. In this case, it will be 5, 6, 7, 8, and the complement of this will be r has a value 0, 1, 2, 3, 4. Okay, now in this case, as r has a greater than or equal to 1 has a number of values, so we use its complement as r less than or less than 1. So evaluating probability of r greater than or equal to 1, we put it as a 1 minus probability of r less than or equal to 1. Now by putting here 1 minus p of r less than or equal to means r has a value only 0. Okay, so now taking p of 0 as putting r is equal 0 in this formula of binomial distribution p of r, we get n as 8c0, as p is a half raised to 0, as q is a half raised to 8 minus 0. Now evaluating as a 1 minus p of 0, here by calculation we get 0. 1 divided by 256. By simplifying this, we get the value as 0.996. That means getting at least one success, that is getting at least one time head, has a probability 0.996.